Hello everyone, welcome to IGC. Am I audible? You guys can respond quickly. Okay, so let's start today's session. Okay, so today we'll be discussing three papers for mechanical vibration part from GATE Aerospace Engineering 2015, 2016 and 2017 paper. So let's start with 2015 paper. So you guys can see there are total three questions from 2015, and one question is for 2 marks and two for 1 mark. So total weightage is 4 marks. Okay. So let's read the first question. What it says: a linear mass spring dashboard system is overdamped. In free vibration, these systems undergoes. So there are four options: non-oscillatory motion, random motion, oscillatory and periodic motion, oscillatory and non-periodic motion. So we all know, guys, in case of under damping, the response is what? Guys, for under damping, what is the response? What is the response for under damping? It's always oscillatory response, right? Now, guys, for critically damped, critically damped and overdamped system, what is the response? What is the response? For critically damped and overdamped system, the response is always non-oscillatory. The response is non-oscillatory. Okay. So what is the answer? What is the answer, guys? The A is the answer. A is the answer for this question. See, usually for any mechanical system, the motion should not be random. It will not be a random motion. Okay, it will be not a random motion. Usually, random motion is for the earthquake kind of system. Okay, when earthquake happened, then the vibration will be random vibration. So the vibration for any mechanical design, it can be oscillatory or it can be non-oscillatory. So the answer is A. Now one more thing: what is critical damping? What is critical damping? Hmm? This is also known as what? Minimum damping. Minimum damping for which system have what? Oscillatory or non-oscillatory motion. So it's a minimum damping for which system will have what kind of motion? Oscillatory or non-oscillatory motion? Ashish, what will be the motion? Oscillatory or non-oscillatory? So it's a minimum damping for which system will have what? Will have non-oscillatory motion. Okay, that's one thing. And critical damping, for which critical damping, for which systems take what? Critical damping for which systems take what? Takes minimum time, minimum time to come to rest. For which system will take minimum time to come to rest. Okay, clear? If your damping is what more than critical damping, the system will take more time or less time. So more the damping, more is more sluggish is motion. Question. Okay, so you guys can see the plot for damping. If it is a critically damped system, the system will take least amount of time. More the damping, okay, more the time it will take. Okay, system will take more time to come to rest. Clear? Okay, so now one more thing. Usually, any mechanical system will have what kind of damping? For any mechanical system is designed for what kind of damping? Under damping, over damping, or critical damping? There is one gate question, right, in gate aerospace. For landing gear system, what kind of damping is used? What is the preferred damping for landing gear system? Swastik. So always any mechanical system is designed for what? Critically damped system. Because you never want oscillatory motion, you also do not want the system takes more time to come to rest. Okay, so system must be critically damped. Okay, so that's all about that question. Now guys, what is the oscillatory motion? Most of you are aware, right? Oscillatory motion means it's either sinusoidal motion or cosine motion, right? Now periodic and non-periodic also you know, right? What is the periodic motion? What is non-periodic motion? What is the damped motion, right? So in case of damping, your like in every cycle your amplitude will get decreased, but your system will theoretically take infinite time to come to rest. Okay, let's see next question what it says. A zero point 0.5 kg mass is suspended vertically from a point fixed on the earth by a spring having a stiffness of 5 Newton per mm. The static displacement of the mass is. So guys, here they have given mass and they have given stiffness, right? So guys, one thing, stiffness is given in Newton per mm. So first thing what you do, you convert this stiffness to what? Newton per meter, right? So if you convert this given K, which is what 5 Newton per mm to what? Newton per meter. What you get? 5 into 10 to the power 3 Newton per meter. Now we all know, guys, what is the natural frequency? Omega is given by either under root k by m, or it is also given by what, g by delta static. Okay, so in your question guys, they asked what, delta static. Now G values they have not given. We know standard G value is 9.81 meter per second square, or you can take approximately 10 meter per second square. What is the unknown? This delta static displacement. And we know this from where it came. It comes from this equilibrium. What is the equilibrium? Your mg will be equal to what? Your mg will be equal to what, k times delta static. Okay, so from here you can see what will be the delta static. It is mg by k. Now what is your m? M is 0.5, g is 10, then it is 5 into 10 to the power 3. So what we get from here, delta will be 10 to the power minus 3 meter, or it is what, 1 mm. They asked value of delta in what? They asked value of delta in mm. So what is the answer? What is the answer guys? 1 is the answer. So what is the answer for this question? 1. Okay. Now if you guys want to see how this mg equal to delta static, so you can consider one spring hanging, okay, and a mass of m is hanging with this spring. So this is what spring mass system under gravity. Now guys, what happens, due to weight of this mass, there will be some static deflection in spring, delta static. So there will be a new equilibrium position for this mass. There will be a new equilibrium position for this mass, which will be what, this. Okay, and in this new equilibrium position, your mg is acting downward, and you will have a spring force which will be what, k times delta static. So that's why you guys can see I have written mg equal to k delta static. Clear guys? So this question is clear, yes or no? Okay, so let's move to next question. What it says, so today's all questions are very easy. In 2015, 2016 and 2017, they asked all easy question. In fact, 2017 question is also easy, but you need to know that concept. We will see that as well. So read the question number 54, what it says. The following data is for a single degree of freedom system with viscous damping. The mass is 10 kg, spring stiffness K equal to 2.25 K per mm, damping coefficient C equal to 0.0125 Newton second per mm. So what is asked? The ratio of any two successive amplitude is. So guys, we all know what, from here, first thing what we can find, zeta, which is what, damping ratio or damping factor, which is what, C by Cc. What is Cc? It is C upon 2m, sorry, or we can write 2 under root km, right? This is what zeta. So find out zeta. One more thing again guys, it is better we convert all the unit in Newton per meter. Okay, so first let's, K value will be how much? 2.25 into 10 to the power 3. Okay, it is not K per mm, it is Newton per mm. It is Newton per mm, guys. This is typo. Now, what will be the C value? The C value will be 0.0125 into 10 to the power 3 Newton second per meter. Okay, now guys, substitute everything here. So it is 0.0125 into 10 to the power 3 upon 2 under root, it is 10 into 2.25 into 10 to the power 3. So guys, first find out zeta. How much zeta value is coming? So here one mistakes usually student will do, they will not convert unit properly, because we should not keep in Newton second per mm. Okay. Otherwise, since here it is in square root, so we may do mistake. Yeah, tell me guys, zeta value. Anybody? How much zeta will come? Yeah. So it is 0.0.0416. Now guys, you know zeta, right? And we already know guys, we already know logarithmic decay. So what is the logarithmic decay? We know all right. Logarithmic decay is nothing but it is ln of it is ln of ratio of two successive amplitude, right? This is what delta, or it is also written as what 1 by n ln of x naught by xn, right? Now in this case they just asked what the ratio of two successive amplitude, right? So we will use this formula, right, considering only one cycle, right? So guys, what is delta, which is logarithmic decay. We also know this is equal to approximately equal to what, 2 pi zeta. Now guys, what will be x1 by x2 then? It will be e power 2 pi zeta, right? So x1 by x2 is that. Sometime again student do mistake. Instead of finding x1 by x2 in exam, they find ln of x1 by x2. They just answer delta itself is the answer, but no, it is what, e power 2 pi zeta is the answer. So e 2 pi, what is zeta? It is 0.0416. So tell me guys, what is the answer? Now you guys will tell me why I always use approximation for delta. Actually it is nothing but what, 2 pi zeta under root 1 minus zeta square. This is what the actual formula for delta. But guys, since zeta value is very less, so either you do calculation for this and you find this, or those will be almost same. So find out guys, x1 by x2, the ratio of two successive amplitude. Quickly. No, Ashish, please check. I think it should be 1 point. Yeah, 1.29 is correct answer. 1.29. So be careful about your calculation, because guys, as a human we all do silly mistake, and I also do a lot of silly mistake. Ashish, it is, the answer is 1.29. So whoever is doing less silly mistake, they will have better result. Okay. And how to avoid silly mistakes? Like during exam you need to be more focused, you must read question thoroughly. During calculation also be in present, don't think here and there, be calm, be composed. Okay. Swastik, so are our efforts helping you? Are you getting confidence now? Because you remember You called me several times, and I told only one thing: not to worry for anything. You need to put more and more efforts, right? And follow the right path, which always IGC provide. Yeah. So let's move now to next paper. Only three questions were there from 2015. So 2016 paper for aerospace engineering. So in mechanical vibration, there are only two questions. One is for 1 mark and one is for 2 marks, and total weightage is 3 marks. So let's read this question what it says. The effective stiffness of the spring mass system as shown in the figure below is. So now guys, this question is in fact not from vibration, it is from basic mechanics, and you all know, right? If you see this spring mass system, there are total three spring. Okay, there are total three spring. One is here and another two. Now you tell me, these two spring, Swastik, are in series or parallel? So these are in series or parallel? These springs are in what? Series, right? So for spring which are in series, what is the K equivalent? It will be K1, K2 upon K1 plus K2. So what will be equivalent? It will be 1 Newton per mm, right? Now, what you see when you find equivalent of these two, you will see the system will be like this. Okay, so this mass is m. So this is what 4 and this is what 1. So what will be the K equivalent final? It will be 4 plus 1, 5. And what is the unit? Unit is Newton per mm. Now guys, what they asked? They asked only K value. So what is the answer? And they asked it in Newton per mm. So 5 is the answer. Answer is 5. Now guys, if they ask find the natural frequency, then you need m value. M need to be given. Okay, m need to be given. So this was easy question from engineering mechanics. Read this question what it says. The governing differential equation of motion of a damped system is given by m d square x by dt square plus c dx by dt plus kx equal to 0. So this is nothing but what? Mx double dot plus cx dot plus kx equal to 0. So this is what? Single degree of damped system, right? Now here m is given as 1 kg, C is given as 2 Newton second per meter, K equal to 2 Newton per meter, what they ask. Then the frequency of the damped oscillation of this system is. They asked what is the damped natural frequency. Okay, damped oscillation. The frequency of the damped oscillation. So first thing guys, what we can find? We can find zeta value. Okay, we can find zeta. So usually what is the zeta guys? The zeta is what? Damping ratio or damping factor. It is what? Damping ratio. This is also known as what? Damping factor. Okay, and zeta is given by what? C by cc. Now guys, c is given. What is the cc? We all know it is 2 under root km, right? So guys, find out. Here the given all units are in SI, so directly we can substitute. So what is the c? It is given 2. What is 2 under root? K is how much? K is 2. How much is m? It is 1. So what is the answer? It is 1 upon under root 2. So what, Dongre? Why pi is coming? Why 1 upon 2 pi under root k by m? This is not the wrong. They didn't ask first thing natural frequency. Okay, they asked the frequency of that. They asked frequency in hertz. They asked Ashish 1 upon under root 2. Hmm? Ashish, why you are giving double answer? I was also thinking why it is more than one. Again, Ashish, you need to have lot more focus. Don't be like me. Okay? Clear? So it is 0.707. So that means it's what underdamped system. We know for guys damped system, the damped natural frequency omega d is given by what? Under root 1 minus zeta square into omega n. What is the omega n, guys? It is 1 minus zeta square under root k by m. So find out omega d, guys, the damped natural frequency. It is exactly 1. Is it exactly 1, Ashan? One thing I want to ask you guys, is this format of IGC learning is better than others, or you guys want more fancy things like webcam, board, these, that? So it's almost what? 1 radian per second, right? So what is the answer? 1. So guys, just tell. I want just opinion of you guys. Is this IGC way of teaching is more effective or less effective than showing 3D, 2D, etc., etc.? What do you guys want actually? So one is the answer. So what is the damped natural frequency, guys? Here omega d, it is 1 radian per second. So 1 is the answer. Okay. So let's move to 2017 paper. So in 2017 paper, which is so called one of the very tough paper in GATE Aerospace Engineering, okay, and there is only one question from 2017, okay. So it is for 2 marks, and let's see that question what it says, okay. So read the question. The natural frequency of the system suspended by two identical springs of stiffness K, as shown in the figure, is given by omega n, which is what? Yes, I'll always. No whole, only learning, right? That's what the motto of IGC. We just want, because learning happens by hearing, not by just watching. So if you hear the right words, if you ask any doubt, if it is solved, then that's where true learning. Yeah. So for small displacements, Both the spring makes an angle of 45 degree with the horizontal with the horizontal, they told the value of a. So they given like natural frequency, and here what is unknown, a, and this is what your spring mass is. Now but what actually usually we know, if you have two spring and if they are connected in vertical, so and then what you can do, directly you can find k equivalent, right? We have seen in one of the question, right, previously today only. What is k equivalent? In this case it is k1 plus k2. But here you cannot directly add, right? You cannot directly add. Okay, so what we see, if you take again here your this spring, and this is the another spring. Let me draw more accurately. And this mass is connected like this. Now this spring is making 45 degree, this is also 45 degree. Okay, both the spring making angle 45 degree. Now suppose this mass is moved by some displacement x in downward direction. Okay, so what is going to happen, guys? What is going to happen? If you see here, this along this spring and along this spring, if you see the component of x, if you see along this spring, if this angle is 45 degree, what will be this angle? This will be also 45 degree. Or let's take initially angle theta. Now same way, along this spring, if you take this x is making how much angle? Theta. Clear? Yes or no? Now in this case, if you take the component of x along, suppose this is my spring 1 and this is spring 2. So along spring x, what will be your component of x? It will be x cos theta, right? Same way along this spring, what is your component? X cos theta. Because we already know this angle is equal to this, right? Because here both spring makes same angle. Now when the component of displacement we know along both the spring, what will be the spring forces? Those will be what? It will be kx cos theta. Same way it will be kx cos theta. Am I correct? Yes or no? Now you know spring forces, right? Now these spring forces, you can see, if this is theta, if this is theta, right? What will be this angle? You guys can tell. What will be this angle? Hmm? What will be those angle? You guys can see, right? So those will be what? 90 minus cos theta, right? Sorry, 90 minus theta, yes or no? So this will be 90 minus theta, and here also this angle will be 90 minus theta. Yes or no? Everybody, is it clear? Quickly. Now guys, we know spring force and we know the angle made by those spring force with horizontal. Okay. Now guys, here in this case, all theta is equal to what? 45 degree, right? Because this spring is making angle 45 degree, right, with horizontal. So when you find this angle theta and this angle, it will come 45 degree. So this 90 minus theta will be also 45 degree. No, that is not corresponding angle. See, theta will be with vertical, Mr. Hassan. Okay, so if you measure angle from vertical, it will be theta. Now you guys can see this spring force will be resolved in two components. One is horizontal, one will be vertical. So what will be the horizontal component of spring force? They will cancel each other. And what it will be? It will be, if you take angle from vertical, then it will be what? It will be kx cos theta sin theta, and this is also what? Kx cos theta sin theta. Now, what will be the vertical components, and both will get added. So what it will be? It will be kx cos square theta, right? So it will become 2kx cos square theta. Clear? Now, if you take the equilibrium of this element in vertical direction, what are those two forces acting? One is what? Mx double dot, and another is what? 2kx cos square theta. Clear? Yes or no, guys? Now, from this equilibrium, what will be your equation of motion? What will be your equation of motion? It will be mx double dot plus 2k x cos square theta equal to 0. So what will be your natural frequency? Your natural frequency omega n, for this case is, it will be what? It will be 2 cos square theta into k by m. Now what is the cos theta here? What is the cos theta? 45 degree. So what we find? We'll find 2k by 2m. So what we find? Natural frequency in this case will be under root k by m. So what is the value of a there? They have given omega n as what? A under root k by m. So this we got what? Under root k by m. So what is the value of a? What is the value of a? Sashish, Swastik, Hashan, what is the value of a? Now guys, similar question. Similar question is asked in what? Gate XC in some years back. But in that case, what they gave? They didn't give theta as 45 degrees. So a value is coming as what? 1. What is the answer? A is 1. Okay. What I was telling, okay, here the space is not there. So they have given one question in gate XC. In that question, how they have noted, they have given like this. Okay, and they gave this angle theta and this angle theta. Okay, so you have to find what? Natural frequency for this spring mass system. So what will be the answer? This will be your answer. Clear? Everybody, is it clear? Okay. So similar way you can solve. Now again, if you see question, what you have to do? Suppose your mass is displaced downward by displacement x. So you can see this displacement x makes what? Theta angle with both the spring. Okay, now what will be your displacements along spring? These are nothing but x cos theta, x cos theta. So these are my spring forces, kx cos theta, kx cos theta along the spring direction. Now these spring forces need to be resolved. horizontally, vertically. So your horizontal components got cancelled. So in your equilibrium, in vertical direction, both got added, and it is what? 2kx cos square theta. Now what is your equation of motion? It is mx double dot plus 2kx cos square theta equal to 0. So your natural frequency is what? Omega n. It is under root of 2 cos square theta k by m. Okay, and we know here theta they mentioned 45 degree. So your A is 1. Clear everyone? Is this question is clear? How to solve such question? Yes or no everyone? And guys, in vibration, I usually always use Newton's method. You can solve every question if you know how to make equation of motion using Newton's method. Clear everyone? Yes or no? So if you guys have any doubt, you guys can write in chat box, and I'll be happy to answer. So if you guys are looking, or those who are watching this session now or in future, if they are looking for any gate or PSU related support from IGC for aerospace engineering, can always contact us on this number or mail us, or can visit our website. Our upcoming batch for gate 2025 is going to start from Feb 18th. That is, as usual, always we start our first batch in Feb, third week, and that will be a kind of year-long batch where we teach everything in depth in very smooth way, because we get the sufficient time compared to July batch. Okay, Ashish, you know, right? In July batch, we get very only 6 month time, but in Feb batch we get around 9 month of time. And you guys can always join our Telegram groups for daily quiz, for other updates related to jobs and all. And you guys can also subscribe to our YouTube channels. We have two channels. One is Gate Aerospace Engineering channel, and another is iitiansgateclasses official parent channel. So that's all from my side, and that's it. So next session today is for aerodynamics, and it will start by 8:15, and after that we have 9:30 flight mechanics session. Okay, done guys. So any question? No question. So thank you guys.